graphically. I don't know what systems mean. I don't know what solving means. I sort of know what graphically means. I know, that's what I'm going to teach today. I'm going to teach all of these things in one lesson. Learning goal, determine the number of solutions a linear system might have and then solve it graphically. So these learning goals tell you, they should almost be at the end of the lesson, right? At the end of the lesson, do you think you can do this now? Yeah, so this is what I'm going to teach today, how to do this. Recall, the solution to a linear system is when the point satisfies both equations. Ooh, there's going to be two equations now. For the rest of the chapter, there's going to be two equations we have to work on. We're looking for the x and y that solves both equations. It's true in both equations. So given two linearations, the ordered pair xy is the point of intersection. Okay, if we want to find these solutions, we can do it graphically. We could just graph both lines. As the lesson goes on, we've got to talk about why graphing is not the most powerful technique, but it's nice. It's nice. When it works, it's beautiful. 3 methods to graph a line. Ooh. 3, you say, Mr. Todd. What are the 3 methods to graph a line? I'll be ecstatic if we get 2 of them, because you might not think of the third one much anymore. Does anyone know one way to graph a line? With a graph. But how do you get the graph? Like, how do you decide on the graph? Like, if I give you an equation, what do you do?
You put it on the graph.
Oh yeah, using what?
Pencil.
A pencil. What do you look for mathematically, though?
Numbers.
Which x and y? Yes, but which 2 numbers do we need for the line? If we're going to do a line, there are 2 specific numbers that we need.
Independent variables.
Absolutely. X and y. We're going to need x and y in there. He's giving all right answers, and I haven't set him up properly. If I give you an equation, say y equals 2x minus 7, what would you do with that 2 and that 7 to graph that thing?
Oh, you put the 7. Yeah, y-intercept.
Good. Yes. Okay, so that's what I was looking for. I didn't phrase it very well for him, so he was wondering what I was up to. So I'll put here the way you know most of all, and the way you should know most of all, is y equals mx plus b. You're like, I don't quite remember. It was pretty good on the test. Most people nailed down y equals mx plus b on the quiz. Maybe they messed up the negative. That's the worst thing that I saw happen, pretty much. So this will be the slope, and the number here will be the y-intercept. And I'm going to review that later. Hopefully, you at least go, oh yeah, I remember something about that, doing with the slope and y-intercept. Before we did slope and y-intercept, though, to teach where slope and y-intercept came from, sometimes we'd build a table of values. And many of your teachers may have called this a T-chart. Do you remember calling it a T-chart? Any teachers call it a T-chart? Well, in high school, we generally call it a table of values, but there's nothing wrong with calling it a T-chart. There was a third method, which is get x-intercept and y-intercept. So it's the intercepts method. And I'll touch on that method, but really 1 and 2 are where it's at. 1 if we can, 2 if we're stuck. 1's much faster. And I'm going to review that almost immediately, okay? Any questions about that? Again, a reminder. If I go too fast, and I had someone in the math help room the other day asking me because they said, oh, my teacher's going too fast. How can you help? I said, you have to tell them. Teachers don't want to go too fast. They don't. But we also don't want to bore you, okay? But so yeah, I'll ask a lot of times, but if I forget to ask, you can just reach up, just like you do on your iPad, you just swipe backwards to go back to the last page. You just tell me, okay? Keep me posted. Here it is. This is what this lesson's all about. Now, it gets a little sidetracked after this, but this is what we want to get to. We solve the system graphically. We want to know the x and y that works on both. The plan seems easy. Graph them both. And once we have them both graphed, we should be home free. So here I am reviewing the method. Which of these 2 lines is easier, actually, to graph using y equals mx plus b? He says y equals 2x plus 1. You might think differently. But 2x plus 1 can be easy. What do we have to do with the 2 to help us with the slope? For once in our life, We actually want the fraction.
2 over 1.
2 over 1, okay? So most of you nailed that down. The only thing that really went wrong, and I'll just mention it now, is missing the negative when you did that, okay? So that, okay. Hey, what happened here? My elbow hit the screen and it went backwards. That's funny. So, to show all the steps, if this is a problem for you, you identify for the first equation that the slope is 2 over 1, and the y-intercept is 1. And we know slope is rise over run, and suddenly that's all the information I need to graph the line. The y-intercept is 1, and to get other points, I rise 2 and run 1. Watch me do it. Rise 2, run 1. Rise 2, run 1. Rise 2, run 1. Now, I do a lot of points on the screen because it's tough for me to draw lines on the screen a little bit to get them lined up. You might only do a couple and go, I got it. You might find in this homework some extra points will help because we really want to get this right for what's going to happen next. So I'm going to add a bunch of other points, and I encourage you to get a lot of points. There it is. Now I'm going to get my straight line tool. There it is. Oh, it's already in red. I'm excited. And then, friends, if your grade 9 teacher lets you away with not labeling these, that's okay. I think if I had been your grade 9 teacher, I would have let you away with not labeling it too. But we better now. There's reason. You're going to see in a minute. We better label them now. That's y equals 2x plus 1. I'm going to do one better. I'm going to switch to blue for the other one so you can really see the difference between the two. And then you do it all again. I wondered if someone would say the second line was easier because it's already a fraction. I got to watch out for the negatives here because the negatives here is the only thing that really messed people up on the quiz. So this one, slope. Ooh, I got a negative. Maybe this is what messed people up. You're like, where does the negative go? Does it go out front in slope? Does it go in the numerator? Does it go in the denominator? The answer is it can go in any of those places. You got your choice of where to put the negative, but you only get one negative. You got to choose where to put it. I always put it in the numerator. And I encourage you to put it there as well. I think that's the easiest place to put it, me personally. And then, oh, that's the rise and run. And I'm writing rise and run beside it. Maybe you don't need to write that, but if you're having any trouble with these, that's what's going on. That's the rise and run. And then the y-intercept is -6. And a couple people, when the y-intercept was negative, just wrote 6, put the y-intercept up there, and that messed them up a little bit. So watch out for that when you get your quiz back. So, and I made this one up on purpose. Watch what happens here. And maybe on your graph paper, like if you're using a regular big piece of graph paper, maybe this wouldn't happen to you because you had a big piece of graph paper. But if I try to rise -3 and run 2, it goes off my page. Some of you are shaking your head like, well, I just get a bigger piece of graph paper. That's not going to slow me down at all. But let's just think this through a little bit. If I want the point that's to the left, then I want the point that rose -3 and ran 2, but ended up there. That's how I think it through. As I go, okay, what point do you rise -3? So you went down 3, right 2, and ended up there. And so I can go backwards and get that point. And you can already see why I suggest getting a lot of points in this, because then you can see exactly what it is. So take a look to see what I did. I just thought backwards. I went, okay, this point here, if I went rise -3, run 2. Geez, it wants to do my touchscreen with my finger. What if I use the back of the pen? Does that? No, that doesn't work either. Is there anything I can touch the screen with? That doesn't mess it up? Okay, rise -3, run 2. That's the proper point. So now I've got the pattern. Now, I've said that before in a class, and somebody said, can't you just make sure that your line has negative slope? Isn't that all we got to accomplish here is make sure it... Oh, I've made a mistake there because I was talking at the same time. I just have to make sure because it's a negative line, negative slope line, it's got to go down. As long as I make sure of that, am I okay? I don't have to overthink this? And the answer is, well, yes. So then, where was it? It was here, here, stop that, and there. That will make my line nice and straight. Well, I would totally get it if at that moment in the lesson you were bored. You're like, didn't we do this in grade 9, graphing lines? Why are we going over this so carefully? Well, I'm trying to gather everybody up. But you're right. All of that is review of grade 9. And if you remember all that, great. However, here's the grade 10 part of it. The grade 10 part of it says, to solve the system, I'm trying to find the x and y that is on both lines, that works for both. It's not a big lesson, folks, I know. But that's all that I got to do extra from what I did in grade 9. In grade 9, I graph both lines, and then I go, where do they meet up? I'm going to write this carefully. Therefore, the point of intersection is -2, -3. But here's the sentence you really want for grade 10. That is, the solution to this system of equations. Boy, what a fancy name for the fact that I just had 2 equations. A little foreshadowing there for you. Maybe later there'll be 3 equations or 4 equations. Not in grade 10, but moving forward. So we call it a system. As soon as there's more than one, we call it a system. The solution to the system of equations is x equals -2, y equals -3. And I don't care which way you write it. That's not the point of my sentence. My sentence is, when they're whipping around this big sentence, solve the system of equations graphically. What they mean is, solve for the x and y that is on both lines. Any questions about that? So those of you who are looking at that worksheet from the first day of the chapter, where I said, oh, all you can do is come up with the equations. Now, the ones that you could graph, you could get the solutions by graphing. I wouldn't go do it. My own personal advice, don't go back to that worksheet just yet. Give me at least one more day. I'll show you one more method. Then you can start looking at those that were on the worksheet the first day and go, which method do I like for these? It's meant to be a worksheet that you look at over the whole chapter to understand the big picture. This says something else. Check your answer using technology. And the reason I put that in there is because I really, really want you to have some technology to help you check your answers. And the technology I like the best, whether it's at home on a computer or it's a great app on your phone. It looks the same, pretty much the same either way. It's called the Desmos Graphing Calculator, D-E-S-M-O-S. And then you can just put these in there. What was the first one? Y equals 2x plus 1, was that the first one? And the second one was y equals -3 over 2x minus 6. And then you can click on the point, you see? And it's got it right there. So great for checking answers, great for knowing, seeing what's going on. You're like, I can't get the right answer. Because sometimes the back of the book, you get a different answer than the back of the book. And you're like, well, okay, I know it's wrong, but I don't know what I did wrong. You bring it up on Desmos and go, oh, that one was supposed to be negative. I get that now. Yeah, very, very helpful. Okay. Any questions about Desmos? All right, back to the lesson. If you're right with me, hopefully, some of you are like, well, that's fine, Mr. Todd, but you picked 2 super easy equations to do. That's actually not my problem. I was pretty good at graphing. It's the algebra that got me a little bit. And so we better practice one with some slightly scary algebra. So if you've drifted off to sleep on me, I totally get it. But you better come back now. This is the example you want to see. This is the one that causes people problems. Yeah? And I have a backup activity ready to go for tomorrow if we have trouble with these. If we don't, we move on. But I've got a backup activity. So if you have trouble with these, you let me know, because I got a fun activity to try. So I ask you the question. What's wrong with these two equations if we wanted to do what we just did? They're not in y equals mx plus b form. There's two possibilities at this point in the lesson. Either you know exactly what he's talking about, or you're like, I don't know what he means. It doesn't matter where you're at. It just changes how closely you're going to pay attention the next couple minutes. He looks at those and goes, they're not y equals mx plus b. And not y equals mx plus b means it doesn't just isolate y. That's what we're really talking about, is isolating y. And I'm up to something else. Tomorrow's lesson talks a lot about isolating y. And so we better get good at isolating y. And on purpose, I chose two that's got a curveball there. And let's look and see if we can recognize the curveball, because this curveball is what messes even very smart people up. Can anyone with a little bit of knowledge help warn people the curveball that is in both of these equations? Can you see it coming? This is an important detail, baseball players, to first know it's a curveball. Then you've got a chance of hitting it. What's the curveball? They're both negative y's. Cruel. So we got to spend a couple minutes talking about how to deal with negative y. I've got two ways to do it, and so I'll make some space here for each of these equations, and I'll do it two ways. You can choose which way is best for you. The first way is like, I totally am so good at algebra. The second way is like, algebra gets me a little bit. I want to have some methods to handle negatives. Here's all the steps. You start with equation 1, and you go 2x minus y equals 1. If I'm trying to isolate y's, the x's got to go to the other side. And the way to do that is subtract 2x from both sides. And I really want to do this carefully, so I'm going to use some color coding here so you can really see what I'm up to. My first move is to subtract 2x from both sides. Now, if you're so good at algebra, you don't write that step anymore. That's fine. If you write that step every time, hey, I'm with you. Great. I love that step. It really shows what's happening, that you're subtracting 2x from both sides. That's how you're able to stay in balance, but it gets the 2x gone. Now, here it is, friends. Here's the mistake that gets made time and time and time again. You get so focused on the x's, you don't notice that that y has a negative out front. I get it. Some people are like, no, let's subtract y. I'm like, well, in a minute it's about to be negative y. You're like, hold on, stop. Don't mess me up, Mr. Todd. In that equation, right up there, is that negative y or is that subtract y? And here's my answer. Yes. It's negative y or it's subtract y, depending on what you're trying to do. If I'm going to put it with the 2x, it's subtract y. If the 2x leaves, it's now negative y. No math trickery, nothing on my sleeve. I don't even have sleeves on today. No, I'm not pulling any tricks. Because really, it can be thought of as add negative y, which is the same as subtract y. So for once, math actually conspires to help you out here, that negative y or subtract y are interchangeable. But you can't lose it. That y is negative, or it's subtract. It's on the left side of 0, one way or another. So this is the line where I see mistakes all the time. Not handling that negative. I'm going to show you another way. If that messes with your brain, I'm about to show you a different way to handle the situation. Next, is it now y equals? Almost. It's negative y equals. So I'm actually going to divide both sides by negative 1. And then I get y equals negative 1 plus 2x. And to really make it y equals mx plus b, I'm just going to exchange the order of those two things so that I can see it in y equals mx plus b form. Now, This last line really shows off that, is that negative 1 or is it subtract 1? It depends where I put it. It's negative 1 if it's out front, but it's subtract 1 over there, and that's all okay. That will work out just fine. Okay. Now, if that scares the beans out of you, you might like this move. Some people won't like it. Some people will think that I'm doing some math trickery, but it's really legitimate. If I take the 2x minus y equals 1, and I notice the curveball and see, oh, that's negative y, I don't like these ones. Mr. Tao, why do you put these ones on there? I don't like that. Go the other way. Put the y's over here. It solves all your negative problems. If I instead do it this way and go 2x minus y, I'm going to move the y to the right side. Very upsetting, rule followers. I know there's a whole bunch of rule followers in here like, no, Mr. Ta, you cannot do that. My teacher said isolate on the left. Well, if it's bothering you, then I definitely think you should stick to method 1. But watch what happens while I convince you that this particular rule break is okay. I end up with 2x equals 1 plus y. And when I bring the 1 over to this side, just look at that for a minute and see if you're convinced that it's going to be okay. Y equals 2x minus 1 or 2x minus 1 equals y, I think the information's the same. It's disorienting when I first do that, I know. I'm not doing a sales pitch for it. I'm just saying if negatives bother you, this is an option because I never did have to deal with the negatives there. I didn't have to divide by a negative. I didn't have to keep track of the negatives. So if there's negative y's, maybe I could move them over to the right. Just an option there. Okay. So now I'm ready to graph. Y-intercept negative 1. There it is. Slope 2. I don't know, maybe you don't put it over 1. I know what slope 2 means. Go up by 2's. But if you need that 1, then put that 2 over 1, and then it's rise 2, run 1, rise 2, run 1, rise 2, run 1, rise 2, run 1. I encourage you tonight, when doing solving by graphing, maybe you want more points because you want to be really accurate when you go to find that point of intersection. So then I go over here. It's now going like that. I'm not turning it into negative slope. If you're going this way, then the points still has positive slope over here. It just, I have to work backwards to find out what points I need to make it have positive slope. So, I've got a job for you in the next few minutes. Here's what I want you to do. Let's not wait till tonight that we're bad at these. Go over here. Write the other equation, and you try it over the next couple minutes. If you're really stuck, I'm going to do it too, but you can watch my steps, check your steps, and find out how good you are at putting this into y equals mx plus b form and graphing it. Also, I forgot to do something on the first line, so you should also try and think, what did I forget to do on the first line? Then, if you get all that done, and you're really fast at it, get your phone out and download Desmos right now. If it's extra data on your bill, just tell mommy that you were told to do it. Get Desmos, and then you can check it on there. Lots of steps to do. I'll close my mouth for a few minutes while you get a chance to try that, okay? I'll actually take the moment to start returning quizzes. I'm still working on names though, so I'll do my best, okay? There are many I know, and a couple I'm still working on. Jacob. Josh. Peter.
Thank you.
Sanvi? Am I saying that right?
It's Sunday.
Sanvi. Okay, good. I'm working on it. I'm working on it. Sanvi. Good. I got that now. Tim. Wait a minute. Tim. Right. Okay. I had to stare for a second. Ellie.
Is it this one?
Desmos Graphing Calculator. Yes, that's the one. If you're supposed to only download things at home, you can wait till you go home. I get it's fine, but N good? N good. There you go. Aiden. Emily. I know, of course. Of course. Aubrey. Addison. Gabriella. Chris. Austin. Alina. Alina. Aiden. It's always the negative. It's a saying in calculus. We actually have a saying in calculus.
Twice here.
Yeah.
One there and one there.
But now that we've talked about it again, you're like, okay, now I'm watching for the curveball. Yeah? When I see that negative, yeah. Yeah. Destiny. Oh, there's Destiny. Alex, I know, of course. My solutions page. Zara. Michael. Sasha. Yes? Is that right? That's you, right? Okay. Damn. I did okay in the names. I had to look a couple of times, but yeah. Great job. Gold star. Okay, friends. Let's do this together. See how you did. Let me just get a survey. How many people are going to use method 1 after seeing this? Like, no, I'm not scared of the negatives. Method 1. How many people are like, no, I like this method 2. Let's get over to the right and avoid the negatives problem. Okay, I'll do it both ways then. Beautiful. So, method 1, you'd go move the 3x over. And I'm not showing the extra step this time, but you can do the extra step. I really love the extra step. Then divide by negative 2, which takes just a little bit of thinking to go, this would be positive 3/2 x minus 4. How'd that go? Handled the positive and negatives okay? If you ended up getting negative 3/2 and forgot to cancel the negatives, yeah. That's why we're doing this practice tonight. That's going to happen all the time. And 4 over negative 2, oh, it's not negative 4, it's negative 2. Good, a couple of frowns there. I can see people going, wait a minute. So that's a negative 2. Positive 3/2, negative 2. Good. It's okay? Okay. Method 2, people who might be convinced that they are smarter than the others now. It's like, wait a minute. Why would you mess around with negatives? Look at all the thinking you had to do. And literally, Mr. Todd might have got messed up by the negatives there. They're going to go like this. And then bring this over. Then they'll divide by the 2, and they have less negative trouble. Let's scroll that down a little bit and fix that 2 there. And you see how they do get the same answer. Okay? So then, once you've got that, then you're graphing. Y-intercept is -2. And this is +3. Run 2, rise 3, run 2. Rise 3, 1, 2, 3, run 2. Rise 3, 1, 2, 3, run 2. Rise 3, run 2. And then to go back here, rise 3, run 2. Rise 3, run 2. And going backwards takes a little tiny bit of thinking, because you're like, where was it before this point so that it would rise 3, run 2, and end up at that point? So yes, that takes just a little bit of thought. And so I've got the point of intersection there, -2, -5. Therefore, the point of intersection is -2, -5. Or you could write, therefore, the solution is -2, -5. So you've got some options on what you write there. Do you have questions, though? What questions do you have? Did you check it on Desmos? Anybody download it and check it, and it worked out? Yeah, very good for checking when you make those little mistakes with negatives and so on. Okay. More time there? Do you need more time? Was okay? All right. We cruise. Given 2 straight lines, and how many ways might they intersect? What do you mean? Well, we just saw one way. We saw one of the ways they can intersect. And I'm just doing 2 random lines like that. Case 1. They could meet once. And then I'm going to put if. I'm going to leave the rest blank. Because you might be like, isn't that the only thing that can happen? No, there's 2 other things that can happen. And so we're going to have to come back in a second and go, why is it that the ones that I gave, that one, that I've, case 1 there, and the 2 examples, why did they have 1 point of intersection? Okay, now, challenge. Maybe. You really got to push your thinking to come up with case 2. And I'm going to go back and forth, so if you didn't get that all down yet, that's okay. Case 2, what else could happen here? Destiny. They're on top of each other. Okay, that's going to be tough for you to draw. I'm going to use separate colors, so it won't be a problem for me. But they literally could be the same lines. And I've got a fancy word for it, but you don't have to use my fancy word. You can use, I'll give you 2 different words to use. And if I switch colors and go, so even though it's the same line, to show it, I'd write them just barely on top of each other so you can see in your picture. See mine. See how nice mine comes out? You can see the 2 of them, the 2 colors there. If you've got another color, maybe that's what you'll do. But if you don't have another color, you draw one and you draw the one basically right on top of it. So when you look at it, you go, oh, I drew the same lines. This could be the same lines. Same lines. We call it coincident lines. And here's something weird. They always intersect. That's a weird way to phrase that they always intersect. This happens if, and we'll come back to it in just a second. I'll let your brain bounce around on that for a few minutes. When does that happen? What happens with this line that you would get the exact same stuff? Won't be too hard. This will be the easiest example to talk about. There's a third possibility. Chris has already got his hand out of his holster ready to go. His hand rocketed up there. Do you know the third possibility?
No, same. It happens if they have the same slope and y-intercept.
He's ready. He's ready. I think this is the easiest one. This happens if they have the same slope and I'm going to put and in capital letters for the sake of your notes when you're looking back at this, and the same y-intercept. This won't be particularly hard to recognize when you're graphing. As soon as you put them into y equals mx plus b form, you're going to be like, it's the same line. You know, it's not going to blow you away when that happens. We still have to go back to the other one. But now we've got some basis for what we're looking for here. We're going to look at their slopes and y-intercepts. Okay? I'll go back to it in a second. I'm going to go back to example 1 in a second. But what's the third possibility then? There's a third way this can work out. AP comment coming. In 2D, there's a third way. In 3D, this is different. But okay. In 2D. Okay, I saw Peter's hand up first. I'm going to go over to Peter in a second. We're just going to switch over to lines here to give everybody another chance to think about this. Peter, how else could this work out?
Parallel lines.
Parallel lines, yeah. You have seen those before. And I'll go this way so you don't think that this only applies to positive slope lines. That's not true. And I'll write some sentences about that. Parallel lines. Parallel lines and just to get you used to the new word, I'll use that too, that are not coincident. They never intersect. This happens if yeah, now you're ready. Yeah, the same slope. And I'm going to use capital letters on the word but here, because I think that sticks out in your notes. I had a big and in this case 2. Now I've got a big but, no giggling, in this one. If the same, this happens if they have the same slope, but a different y-intercept. Maybe we don't need to graph here. Maybe we can answer these questions without actually graphing. You go ahead and graph them if you need to, but maybe there's a way. Same slope, but a different y-intercept. How did I do? They're not coincident. Because technically speaking, those last ones were parallel too, but they were coincident. They were the same line. Good, good catch on there. Who's ready for case 1 though? If I go back to case 1 though. Are you ready now that you've seen the other ones? Case 1 would have been hard. What happened here? It's actually simpler.
Different slope and y-intercept?
They can have the same y-intercept actually. Same y-intercept, they'll still intersect at one spot. So you only need the first part. They meet once if they have different slopes. As soon as they have different slopes, they're going to meet once. So my picture shows ones that have different y-intercepts, but if they happen to intersect at the y-intercept, they could have different slopes and still be meet once. Okay, now, the way I did that, you might be all over the place. Do you need more time to write down case 1? Yes? I thought so. They could meet once if they have different slopes. Okay, AP people, just so you know where we're going with this in future grades, in 3D, this first sentence isn't true. You can have different slopes and not meet up in 3 dimensions. A good thing for airplanes, right? You see the little 2 airplanes moving on the screen. Just because you see them over top moving towards each other on the screen doesn't mean they're going to hit each other. One could be at 1,000 feet and the other one at 5,000 feet, and it's no problem. So 3 dimensions, it's not that much harder than what we're doing, but we got to get to 3 dimensions eventually, and we will. The course called Calculus and Vectors, both of those calculus courses, go, let's do it in 3D now. It's not a big deal, really. Do you need more time on case 2? Do you need more time on case 3? And I've only got 1 slide left. I can predict what's going to happen. They're going to give me some equations, right? And I'm going to decide by looking at them. Ooh, Without graphing, determine the number of solutions. You know what? We got to get better at predicting curveballs. Got to get better at looking at questions that are difficult. Which one is the easy one here? There's one of these three that is like, this is going to take no time at all. B. What is it about B that makes it that this is going to be straightforward? RD and Y equals MX plus B form. That was the big lesson in grade 9 that maybe only became clear now. In Y equals MX plus B form, we're ready to go. And you only have 3 lines of thinking that you have to do here. You go, same slope, different y-intercept. I'm ready to make my conclusion. While I fix my writing there, is there anyone who now can make the conclusion about the number of solutions that they have the same slope but a different y-intercept? They're parallel lines that aren't coincident. So how many solutions? How many times do they meet? None. No solutions. If you graph them, they will not meet up. Now, friends, tomorrow, I challenge you to remember this example and challenge me to try and solve this one using the method I'm going to show tomorrow. So keep that in your back pocket. You want to throw me a curveball, you're like, oh, spend your whole time throwing us curveballs, Mr. Todd. Here's a curveball. Let's talk about B from yesterday. All right? Just keep that one in mind. Okay. Okay. What a mess. Which one is the easier of the two that's left? I have a definite opinion about which one I think is easier of what's left. You like C? Okay, we'll go after C. I'll do C, then you're going to do A. You're going to try it out. A's easier? Which one? I'll do whichever one you say. That's not, no problem. But for the record, which one's more difficult? C is more difficult. There's more work to do. A is more difficult. It's got that nasty -6 out there.
Oh, wait, no, it's C.
So you want me to do the harder one? Okay, I'll do C. C. Getting ready for tomorrow. Number your equations. This is one of the big things about tomorrow. When you have 2 equations, you better number them because they both have x's and y's, and it's easy to get confused. So I'm going to work with equation 1 for a minute. And I'm going to do this one using the first method I said. Move the 3x over. Divide by the -2. And I get y equals 3/2 x minus 4. Equation 2, much easier to work with. I only have one little thing to do. It doesn't have a negative in front of the y. So I get y equals -4x plus 7. Without graphing, I have 3 lines of thinking I have to do. This has different slopes. Different y-intercepts, even though I actually don't care about that. But if we have different slopes, how many solutions will we get? One solution. If that's not perfectly clear, go ahead and graph it. I know it says don't graph it. Like it told me not to graph it. I'm like, how am I going to know if you graphed it? Like if this question was on a test, really, how am I going to know if you just took out a graph paper and graphed it real quick just to make sure? The implication of the question is there's a way to do it without graphing, and maybe you should think about why that is. Not why that is. Why, W-H-Y, that is. All right, you take a minute and try A. See how that goes. This is the big game today. Can we rearrange into y equals mx plus b? Try A, and I'll start it in just a second after I'm sure everyone's copied down C, and then you can check your answer to make sure you're ready for this homework.
Oh, did you drop it?
Here I go. So you can compare your steps as you go. I'm going to do this the other way for the people who like the other method. How'd it go? Is good? Yeah, ready for negatives a little more now? Good? So, what I see is different slopes. That one's 2/3, that one's 4/6. Are they different? No. Okay, now your math history has got rocked a little bit, where you're like, oh, that reducing fractions thing, it had nothing to do with torturing us. Yeah, it felt like, oh, it didn't reduce your fractions. It was about, you better check to see if 4/6 is the same as 2/3. How do we do that? We all reduce it. If we all reduce it, we'll all get the same answers. So we reduce this fraction. And now we have same slopes, same y-intercept. What's the conclusion about this line? Same lines. Did anyone use the fancy word? Coincident. Okay, you can just say same lines. But I keep using that word just in case it's in the homework. You won't be that surprised when you see it. But I didn't actually answer the question yet. Infinite solutions. I didn't say that before. You can say they always meet. You can say what I said before, but I'll just put that up there because, again, textbooks or other lessons may talk about infinite solutions. There's another one for tomorrow. You want to throw Mr. Todd a curveball? Say, well, why don't you solve that one from yesterday? Show me how to find infinite solutions, and I'll show you how. It's wild. Some wild stuff going to happen tomorrow. Any questions about all that?